Good day, everyone. I am Ma'am Jenny, your science teacher, and today we will be discussing another interesting topic in science. Watch out. On our previous video lesson, we have learned that matter is a material we find in the universe. It is composed of tiny particles called atoms. It exists in three basic phases: solid, liquid, and gas. Plasma is considered as the fourth phase and the most abundant but least familiar phase. On this video lesson, we will talk about the physical changes in terms of the arrangement and motion of atoms and molecules.
Before we discuss our new topic, let us have a review of what we have learned last time. Let us have true or false. First statement: liquids have definite volume. If your answer is true, then you are correct. Next statement: particles of matter holds potential energy. If your answer is false, then you are correct. The answer is false because the particles of matter holds kinetic energy and not potential energy. Third statement: kinetic molecular theory explains that matter is made up of tiny particles called atoms and molecules. If your answer is true, then you are correct. Fourth statement: in lower temperature, particles have high energy. Take note of the underlined word. If your answer is false, then you are correct. That statement is false because of the word lower. It should be higher. In higher temperature, particles have high energy. And for the last statement, particles of matter are always in motion. The answer is true. So congratulations if you get a perfect score. On this video lesson, we will explain the physical changes in terms of the arrangement and motion of atoms and molecules. Matter normally exists as solid, liquid, or gas. We called this property the phases of matter. The three normal phases of matter have unique characteristics. Solid has a regular pattern and particles are tightly packed. Liquid has a fixed volume, can change shape to fill its container, while gas can compress and expand in different pressures.
Most substances exist in three phases depending on temperature and atmospheric pressure. Some substances, like water, can exist in all three phases at ordinary conditions.
Phases of a substance are referred to as phases when they coexist as physically distinct parts of a mixture. When heat energy is added or removed from a system, one phase can change to another.
We will use water as the primary example on the phase changes because the phases of water, which is ice, liquid water, and water vapor, are familiar to you.
What are the phase changes that require energy? What are the phase changes that require energy? We have melting, evaporation, and sublimation. Let's start with melting. When ice cube is placed in a glass of water, it melts. because water has a higher temperature than ice. Heat energy flows from the water to the ice.
Heat transfer is from an object of higher temperature to an object of a lower temperature.
The heat absorbed by the ice is used to break the hydrogen bonds holding the water molecules together in the ice crystals. When the molecules on the surface of the ice absorb enough energy to break the hydrogen bonds, they move apart and enter the liquid phase. As the molecules are removed, the ice cube shrinks. The process continues until all of the ice melts. Melting is a process of changing a solid substance to liquid substance. Let us have this sample activity. What changes take place when ice turns into liquid water? The materials that we need for this activity are the following: 2 pieces ice cubes and 1 piece saucer. Step number 1. Put 1 ice cube on a watch glass or small saucer. 2. Observe what happens to the ice cube after 2 minutes. You may do any of the following. Write a description or draw a cartoon or illustration to show how the particles of water behave as ice changes to a liquid. Let us have our guide questions. Number 1. Explain what is happening to the particles of water in ice as it turns to liquid using the particle model of matter. Number 2. Explain what will happen to the liquid on the watch glass or saucer if it is transferred into a small container and left inside the freezer after a few hours or overnight. Let us answer the guide questions. After 1 to 5 minutes, the ice begins to turn into a liquid. Or we might say, the ice melted. When ice, which is solid, turns into a liquid, the particles or molecules of solid water vibrate faster due to the higher temperature in the room compared to the freezer. Eventually, the particles of molecules break away from their fixed positions and so they turn to a liquid. Number 2. Explain what will happen to the liquid on the watch glass or saucer if it is transferred into a small container and left inside the freezer after a few hours or overnight. The liquid will turn into solid when transferred to the freezer. It is a common observation that when we put liquid inside the freezer after a few hours, especially overnight, from liquid it will turn into solid. So we call it as freezing. Next, we have evaporation. Once all the ice is melted, additional energy added to the system increases the kinetic energy of the liquid molecules. Particles that escape the liquid enter the gas phase. For a substance that is ordinarily liquid at room temperature, the gas phase of water is called gas or vapor. Evaporation is a process of changing a liquid substance to gas substance. At this point, let us have another activity. What changes take place when water is left in an open container in a closed container? The objectives of this activity are the following. Describe what happens to water when it is water when it is left in a closed container for some time. For the materials that we need in this activity, we have 1 cup tap water, 3 pieces clear saucers, 1 piece 1 teaspoon or 1/2 measuring tablespoon. On this activity, I use half glass tap water, saucers. I also use small glasses, we call it shot glass, and a teaspoon. For the first step, pour 1 teaspoon or 1/2 tablespoon of tap water into the watch glass or saucers. This is container number 1. You can write number 1 on a piece of paper and place it under the watch glass. Cover container number 1 and set aside. So let's watch this video clip. This is the setup that I have prepared. So for the first one, I use a saucer. Then I pour 1 teaspoon of tap water into the saucer and then I covered it. Then on the other one that I have prepared, I use a shot glass. So I pour 1 teaspoon of tap water into the shot glass and cover it. So that is container number 1. For number 2, pour 1 teaspoon or 1/2 tablespoon of tap water into the second saucer or any container that you will use. This is container number 2 and do not cover container number 2. So you have here then on the other setup I have also then number 3, put container number 2 beside container number 1 in an area of your room where these can be kept overnight. This is the first setup where I use shot glass and the second setup where I use saucers, one with cover and the other one without cover. So we have to leave it overnight.
Nothing left for container B. While for container A, there is moisture in the cover and the water is still there. So after 1 day, user setup for container B, no more water. For letter A, setup A, there is moisture on the cover and the water is still there.
For our guide questions, number 1, describe what happened to the water in container number 1. 2. Describe what happened to the water in container number 2. Compare the volume of water left in container numbers 1 and 2. Number 3. Where do you think did the water go? Describe this process by writing your description or draw an illustration. Label the parts of your drawing. You can use call-outs in your drawing. And number 4. Would anything happen differently if you heated container number 2? Explain your answer. Alright, let's answer the questions. For number 1, the cover of container number 1 had droplets of water on it. So let's take a look on the videos.
Container A, there is moisture in the cover and the water is still there.
See, you have there droplets of water. Number 2, describe what happened to the water in container number 2. Compare the volume of water left in container numbers 1 and 2. So there is no more water left in container number 2. that the volume of water from an open container decreased after leaving it overnight. In fact, nothing of the 1/2 tablespoon of water was left on the saucer. How are we going to explain this? Based on the particle model of matter, particles are always in motion. Note that the particles mentioned in this case are the molecules of water. These molecules have kinetic energies that differ from each other. Some particles are moving faster than others and therefore have higher kinetic energy, and some are moving slower. So, even at room temperature, some molecules of water have enough kinetic energy to overcome the attraction of neighboring molecules and escape from the surface of the liquid and eventually move into the air. To break away from the surface of the liquid, the molecules must have at least some minimum kinetic energy. For number 3, where do you think did the water go? In container number 2, the water from the watch glass or the water from the saucer turned from liquid to gas and escaped to the air. Water evaporated to the air above the liquid water. And number 4, would anything happen differently if you heated container number 2? Yes, it will be different if container number 2 was heated. In a very short time, most of the water on the surface of the liquid will turn from liquid to gas because the higher temperature will cause the particles of water to move much faster and have more energy to escape from the surface of the liquid. So again, the process by which the molecules on the surface, take note, on the surface of a liquid break away and change into gas is called evaporation. Usually, it is described as the process where a liquid is changed into gas. As evaporation takes place, the water molecules which did not escape and were left in the liquid have a lower average kinetic energy than the molecules that escaped. The effect of this is the decrease in the temperature of the liquid water. Evaporation is a cooling process. You can feel this cooling effect yourself when you apply acetone on your nails or rubbing alcohol on your arms. Acetone and rubbing alcohol are volatile liquids. They readily or easily evaporate. As they evaporate, the molecules get energy from your body, leaving you with a cool sensation. It is important to remember that the evaporation of a liquid in a closed container is different from the evaporation from an open container. In a closed container, no particles can escape into the air outside the cover of the container. Going back to the answer in question number 4, would anything happen differently if you heated container number 2? Yes, it will be different if container number 2 was heated in a very short time. Most of the water on the surface of the liquid will turn from liquid to gas because the higher temperature will cause the particles of water to move much faster and more energy escape from the surface of the liquid. When a liquid changes form into a gas, the process is what we call as vaporization. Take note that evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into gas phase. The surrounding gas must not be saturated with the evaporating substance. When the molecules of liquid collide, they transfer energy to each other based on how they collide with each other. Evaporation is a surface phenomenon. Vaporization is a bulk phenomenon. Vaporization is a fast process, while evaporation is a slow process. can watch vaporization when you boil a pot of water. Next is we have sublimation. Sublimation is a process of changing a solid substance to a gas substance. Solid iodine and solid carbon dioxide or dry ice change directly from solid phase to gas phase. This is called sublimation. Mothballs, which contain the compound naphthalene, also sublime. Have you noticed ice cubes left in the freezer for a long time shrinked? It is because they sublime. Freeze drying is a process where fresh food is frozen. As the pressure in the container is reduced, the ice sublimes and is removed from the container. Backpackers and astronauts use dried foods because they are light to carry. Fresh dried food does not contain water, so spoilage due to bacteria is avoided. Fresh dried foods can be stored for a long time without refrigeration. At this point, let us discuss the phase changes that release energy. So we have condensation, freezing, and deposition. Let's start with condensation. Remember that on the activity, what changes take place when water is left in an open container? The water evaporates. How about in a closed container? In a closed container, no particles can escape into air outside the cover of the container. We have observed that the droplets of water formed under the cover, which covered the second saucer. Evaporation still happens in a covered container. Some of the molecules of water on the surface of the liquid escape and go into gaseous state. These molecules may then collide with the inner surface of the cover, and as more and more of these molecules do so, some may stay on the cover, accumulate, and form droplets. This process, where a gas is changed into a liquid, is called condensation. It is the reverse of evaporation. In a closed container, the molecules of water continue to evaporate and condense, but there is no net change in the number of molecules in the liquid or in the gas phase. Molecules of water that previously evaporated are condensing, but other water molecules are evaporating. There are many other examples of condensation that you may have observed. Condensation is responsible for the ground level fog that we see on some cold days or along the highway leading to Baguio. For your eyeglasses fogging up when you go from an air-conditioned room or a vehicle to the outdoors on a hot day, and for the water that collects on the outside of your glass of cold drink. Just like this one. So, the vapor or the water vapor is condensing. Next is we have freezing. You place an ice cube maker filled with water in the freezer. As heat is removed from water, the molecules lose kinetic energy. The velocity of the molecules decreases. When enough energy has been removed, the hydrogen bonds between water molecules keep the molecules fixed or frozen into set positions. Freezing is the reverse of melting. The freezing point is the temperature at which the liquid is changed into crystalline solid. It is a process of changing a liquid substance to solid substance. And finally, we have deposition. When water vapor comes in contact with cold window glass in winter, it forms a solid deposit on the window glass called frost. Deposition is the reverse of sublimation. When water vapor high up in the air changes directly into solid ice crystals, you get the snowflakes. Energy is released as crystal forms.
Examples of phase changes that release energy to the surroundings are the morning dew you see on the glass window and the beads of water on the garden seats.
The phase diagram. Temperature and pressure are two variables that combine to control the phase of a substance, but they can have opposite effects on the substance. For instance, the increase in temperature causes more liquid to vaporize, whereas an increase in pressure causes more vapor to condense. A phase diagram like this one is a graph of pressure versus temperature that shows in which phase a substance exists under different conditions of temperature and pressure. Note that the three regions represent ice, liquid water, and water vapor phases of water, and the three curves that separate the regions from one another. Along the curves, two phases of water can coexist. At what point in the graph do liquid water and water vapor coexist at a pressure of 100 atmosphere and a temperature of 100 degrees Celsius? What is the normal boiling point of water? What is the freezing point of water? What is a triple point? A triple point is the point on the phase diagram that represents the temperature and pressure at which all three phases of the substance coexist. In the diagram, point A is the triple point. All the six changes can occur at the triple point: freezing and melting, evaporation and condensation, sublimation and deposition. Point B is the critical point. This point indicates the critical pressure and the critical temperature above, which water cannot exist as a liquid. If water vapor is at critical temperature, an increase in pressure will not change the vapor into liquid. The phase diagram for each substance is different because normal boiling point and normal freezing point are different. However, each diagram will supply the same type of data for the phases including the triple point. Before we have our short quiz, let's sum up what you have learned today. Matter undergoes changes. Physical changes in matter may either lose or gain energy. In the process of melting and evaporation, energy is gained. In the process of freezing and condensation, energy is lost. When a liquid water absorbs heat, it evaporates and turns into gas. When a gaseous substance gives off heat, or when heat is removed, it will condensate and turns into liquid. When a liquid water releases heat, or when heat is removed in liquid water or in liquid substances, it will turn into solid or it freezes. While when solid substance absorbs heat from the surrounding, from solid, it will turn into liquid. So we call this process as melting. So melting is the reverse of freezing, and freezing is the reverse of melting. Whereas condensation is the reverse of evaporation, and vice versa. Deposition is when gas substances turns into solid, while sublimation changes solid substances into gas. So these are the major points for our discussion. Alright, let us have a short quiz. Number 1. Which of the following statements is true? A. Condensation changes liquid to solid. B. Melting changes solid to gas. C. Evaporation changes solid to gas. And D. Freezing changes liquid to solid. Number 2. Which of the following will happen when heat is added in a substance? A. Condensation. B. Deposition. C. Evaporation. D. Freezing. and her family had a chance to visit their relative in Baguio. On their way, they have observed that the place is covered with thick fog. Which process is responsible for the ground level fog that they saw along the highway of Baguio? A, condensation; B, deposition; C, freezing; D, evaporation. Alright, let's answer. Number 1, number 2, number 3, number 4, and number 5. If you got a perfect score, then congratulations!
Thank you for watching this video lesson. See you again next time. And don't forget to subscribe and hit the notification bell.